Okay, guys, today's I can statement is, everybody look with me at the board. Today's I can statement is, I can use patterns and mental math to multiply by multiples of 10, 100, or even 1,000, okay? We're going to start today by looking at the sheet you have in front of you. We started this on Friday, but I kind of felt like we need a little extra time. So we're going to go back and look at this. There's also another I can statement right here in front of you. It's kind of pretty much exactly what I just said. It's just a little longer. All right. Let's look first at the top box, okay? What is my first sentence? What's my first problem?
5 times 1.
5 times 1. Well, that's a pretty easy one. What property will we be using with 5 times 1? Identity property. Very good. So 5 times 1 is, because we know any number times 1 is just going to be what? That itself, that other number. Very good. Okay. Now, let's pretend that 0 is not there. Let's pretend it's just a 1. What's 5 times 1?
5.
How many zeros do I have?
1.
So I'm simply going to bring that 1 0 over. And what do I have?
50.
50. Very good. Okay, again, pretend that you don't see those zeros. Let's just look at the first number. Everybody underline the first number. Okay? Let's take a look at those. We've got 5 times 1 again. What is 5 times 1?
5.
5. How many zeros do I have?
2.
I'm just going to drop those 2 zeros down. Just like that. Everybody with me?
Yes, ma'am.
All right, again, let's take a look at this next one. What's 5 times 1?
5.
How many zeros do I have?
3.
Does everybody see what we did there?
Yes, ma'am.
Any questions on that? Do we feel good about that part?
Yes.
Does everybody feel good about that part? Okay. Now, let's take a look at exponents, okay? Let's take a look at exponents. Everybody underline the exponent. Okay? Okay, everybody, with me. We've had a minute to work. Now let's take a look. Okay, we have 10 to the first power. When you see that exponent, what does that little bitty number tell us? How many what we need?
10.
How many tens we need? And we could, if we're just using multiples of 10, how many zeros? Okay, well, let's take a look at this first one. We have 10 to the first power. We have an itty bitty baby 1. That itty bitty baby 1 there tells me how many what I need.
Zeros.
Or how many tens I need. Well, how many tens do I need right there? 1. It has a 1 here. If it has a 1 there, that's telling me all that says is 5 times 10. If you did not write that just like that, go ahead and do that, please. 5 times 10. That's all it is saying to me is 5 times 10. Make sure and write it out like this, like I've got it, exactly like I've got it on your papers. Okay, well, what is 5 times 1?
5.
5. What is 5 times 0?
0.
So we've got, just bring over that 1 0, right? All right, well, here we have a 2. We have an exponent of a 2. What does that exponent of a 2 tell me? How many tens do I need? 2. Very good. And we're multiplying those tens. We're not adding them. We're multiplying them. So that's just saying 5 times 10 times 10. Okay, what is 5 times 1? 5. How many zeros do I have?
2.
So just bring those zeros up. Okay? Does that make sense? Are y'all there? Everybody there? Okay. All right. So now, how many tens do I need on 10 to the third power? 3. Are we adding those tens or multiplying those tens? We are multiplying those tens. 5 times 1 is 5. And then how many zeros do I need?
3.
Go ahead. 3. You're exactly right. Okay. Good job. All right, so let's take a look at the next one. We have 5 to the fourth power. How many tens am I going to need?
4.
So it's going to be 5 times 10 times 10 times 10 times 10. Does everybody agree with that?
Yes.
Okay, so I'm going to say 5 times 1. What's 5 times 1?
5.
How many zeros do I have?
4.
I have 4, 1, 2, 3, 4 zeros, and that's going to be 50,000. All right, so now at your table, it says, what pattern do you notice? I want you to look at this top box first and tell me, what pattern do you notice? Hey, wait a minute, you're going to discuss with your team. Think for a minute. Everybody's thinking right now. Shh, we're thinking. We're not talking yet. Now discuss. Alrighty, back with me. So what do we think here? What do we see? What are we noticing? Somebody raise your hand and tell me what you feel like you noticed. Quentin, what did you notice? Okay, let's do a little bit more depth than just add a zero. Bella?
It goes up times 10 each time.
It's going up times 10 each time. Who's got something different than that? Okay, Caitlin? They're all multiples of 10. Okay, anybody else got anything that you want to say? All of those are really good. They are multiplying by 10. It goes up by a multiple of 10 every time. So all of those would work. Go ahead and pick which one you want to write in your box. Notice the bottom. Is the bottom the exact same thing?
Yes. No.
Is it not going up by a multiple of 10 every time? We have 50, 500, 5,000, 50,000. It is. So each one of those exponents are adding a multiple of 10, because we first start out 5 times 10 is 50. 5 to the first power is 50. 5 to the second power is 5. 5 times 10 to the second power is 500. 5 times 10 to the third power is 5,000. And 5 times 10 to the fourth power is 50,000. Each time, we're multiplying by one more 10, okay? Go ahead and get that written in. Okay, guys, now in front of you, you have this worksheet that I have on the screen. I need you to go ahead and get out your expo marker, get out your worksheet, and we're going to work a few of these together, and then you're going to work some of them you're by yourself, okay? Are we short? Okay, does anybody have an extra? So we're going to take a look at number 1. Everybody should have this one in front of you. We have 80 times 90. All right, first of all, pretend those zeros are not there, that you do not see those zeros. They're not there. They don't exist at the moment. All we have, I want everybody to underline. Give me 1 second. Underline your 8 and underline your 9. All you're doing right now is underline your 8 and underline your 9. All right. So you should be working this on your table. We're doing graffiti math right now. You should be working it on your table. Now, we need to ask ourselves, first of all, what's 8 times 9? Everybody. 72. So we're simply going to put 72 down. Then, how many zeros do I have? So I have 7,200. Who got 7,200 on that one? You had time to work. Excellent. Okay, now let's take a look. Sorry.
I forgot how to do that finger thing.
So let's take a look at our next question. We have, all I want you to do right now is I want you to go in first, before you work this, I want you to underline 5, 1, and 2. We'll go back to it. Just work with me. We'll go back to 2. We're just doing what I've got blown up right now. Okay, everybody with me. Raise your hand if you're there, if you've got your numbers underlined. When you're not using your markers, please put the lids on them. Don't work ahead. Stay with me. All right, first of all, we have an exponent. Let's put a circle around our exponent. How many tens is that telling me I need? 1. So I'm just going to come down here below, and I'm going to write it again. And I know with a 110, you're thinking this is a waste of time, but if you'll get in the habit of doing that, every time you have an exponent, it'll help you. Okay, what's 5 times 1? 5 times 2? 10. Okay, now let's count and see how many zeros we need to add. 1, 2. So my answer would be 1,000. All right, let's take a look at another example together. All right, here we go. Underline your 4, your 8, and your 1. Okay? But what is something that we have that is extra here that we need to circle? My exponent 2. How many 10s is that telling me I need? 2. Do I need to add those 10s? No. What do I need to do? Multiply. Excellent. So we're going to multiply. So now I have 4 times 8. What's 4 times 8?
32.
Times 1?
32.
Times 1?
32.
So we have 32. How many zeros? 1, 2. 1, 2. 3,200. Is everybody with me on that one? Are we there? Anybody need any help? If I need to stop and work something, let me know. No? Okay. Let's go to our next one. Remember, I told you the other day when we were talking about multiplying, what is it always good to try to find? Numbers that end with what after you multiply them?
0.
A 0. Very good. Well, 4 times 30 does not end with it's going to have a 0, but it's going to be hard to multiply with. Does anybody see something up there that's going to be easy that we can think of easily? Bella. No. Ava. Sorry, Ava.
24 times 5.
24 and 25. When we say 4 and 25, what should we think of? Quarters. Very good, because we use quarters every day in our life pretty much, okay? How many quarters equal $1? 4. So we know here we can say 4 times 25, and we're going to have 100. Yeah, give me just a second. We're going to have 100 times 30. Now that is pretty easy to multiply, right? Underline your 1, underline your 3. I have 3 times 1. What's 3 times 1?
3.
How many zeros?
3.
1, 2, 3. We have 3,000. Does everybody understand why I chose to use 4 and 25? Find little things that make your life easier. Work smarter, not harder, okay? Don't make it harder on yourself. You'll find little tricks like that. It'll make it much easier. Okay, what I need you to do now is I need you first to read this question to yourself. I'm going to read it aloud. You're reading with me. You know that 6 times 7 equals 42. How can you find 60 times 700? Take a minute to think. Talk with your table. Okay, guys, I need to go back to a question. I missed something that was very important. So your mouths are closed. I made a mistake, and I need you to come back with me to number 2. All right. We did get 4 times 8 right. What is 4 times 8?
32.
But I missed something that was very important.
So
I only said 2 zeros. I was not looking at that 0. I got in a hurry. So now, instead of having 2 zeros, we should have had 3 zeros. 32,000. Does everybody see where I messed up? Yes. Okay, teachers make mistakes. You go back, you fix it. When you make a mistake, you go back and fix it. So it's 32,000, not 3,200. So that 1 0, did it make a big difference?
Yes.
Yes, it made a huge difference. Okay, so now that we've got that fixed, let's look down here. We have 6 times 7 equals 42. How can you find 60 times 700? Somebody tell me. All right, Jackie, your hand went up first.
You say 6 times 7 counts as zeros, and others said.
She said that she would say 6 times 7 and get 42. Then count the zeros and add them to the end of 42 to get 42,000. Who got 42,000 or something that sounded a little bit like that? Okay, you would first multiply your 6 times 7. You would get 42, and then you would simply count those zeros and place them at the end, okay? Who got that? One more time. Let me see those hands. Good job. Okay, now we're going to flip over to the back side. I want us to scoot down to number 12. You're going to come back and do some more in just a minute. Don't freak out, but I need you to scoot down to number 12. All right, first thing I want you to do is underline the first number, okay? Now, what is something really important that I need to circle?
The 3.
The 3. Very good. On your paper, not on the table, but on your paper. Then you can work it on your table. I want you to write 10 times 10 times 10. And where did we get those 3 tens? From that exponent. Very good. Times 200 times 30. Just like that. Okay? Everybody with me? All right, now we've got it all spread out. We've got those exponents. We've used our exponents. We've written our 3 tens. What do we simply need to do now? Just multiply. That's all we've got to do. Well, if we underline our 3, our 2, and our 1s, what's 3 times 2?
6.
What's 3 times 2? 6. Times 1?
6.
Times 1?
6.
Times 1? 6. Very good. So we're going to just put our 6 down. Now what do I need to do? I've got to count all my zeros. Make sure to get all of them this time, and I am too because I messed up a while ago. I have 1, 2, 3, 4, 5, 6. So I'm going to put down 6 zeros. Here we go. Everybody count with me. 1, 2, 3, 4, 5, 6. Okay, for every 3 over, we're going to put a comma. And we have 6 million as our answer. Everybody with me there? Is there a question about that problem? Okay, what I want you to do now, I want you to work we're going to circle them together. 1, 5, 7, 11. Okay, 1, 5, 7, and 11. Go ahead and get started on that. All right, guys, so let's take a look at this. We've got 2 times 1. Highlight your numbers or underline your numbers, your front numbers. What's 2 times 1? 2. How many zeros do I have? 3. What's my answer? Who got 2,000? Raise your hand. Excellent. I like to see all those hands up. Okay, here we go. Let's go ahead and look at numbers 5. All right, well, we have an exponent. So we're going to underline, and then we're going to write our numbers down. What are we going to have? 60 times 70 times 10. How many 10s do I need? 1. What's 6 times 7?
42.
42. Very good. So let's just drop that 42 down. How many zeros? 1, 2, 3. 1, 2, 3. Who got 42,000? Raise your hand. Excellent. Okay, here we go. Number 7. What's something we need to circle here? Our exponent. Very good. How many 10s is that telling me I need? 2. So I need to put 10 times 10, and then just bring this one down, times 10 times 1. What's 1 times 1?
1.
Times 1? Times 1? What property did we just use? Identitive. Now let's count our zeros. 1, 2, 3. 1, 2, 3. Okay, so let's go ahead. Who got 1,000 on that one? Raise your hand. Excellent. Okay, let's take a look at number 11. All right, what do I need to underline?
7.
My 7, my 5, and my 1. What is 7 times 5?
35.
Times 1? 35. Now, I want you to go, and we're going to count our zeros. 1, 2, 3, and 4. We're just going to put those down. And we got 350,000. Who got 350,000? Okay. So today, at the beginning of our lesson, we had an I can statement. Our I can statement was, everybody read it for me. Freeze. I can.
Use patterns and mental math to multiply by multiples of 10, 100, or... We don't use mental math.
Okay, do you feel like you can do what that statement says now?
Yeah.
Okay, if we don't, raise your hand. Let me see you. We'll work a little more on there, okay? If you need some help, that's why I'm here. But our I can today was I can use patterns and mental math to multiply by multiples of 10, hundreds, or 1,000. So we did that all day today. We used our exponents. If we see an exponent, that tells us how many of the base number we need. Does that mean we need to add those or multiply those? Multiply those. Great job. Okay, homework tonight. You are going to finish the problems on this page that we did not finish, okay? I need you to put that in your binders and go ahead and get out science.